Okay, moving on to example number 4 here. So with this one, we need to factor that denominator so that we can get a better idea of what we're looking at, what's a key point here. So x squared plus 2x minus 3, that would factor to x plus 3, x minus 1. So there's actually two issues here, okay? We have x equals 1 and negative 3 for asymptotes, and those are the two points we're going to have to analyze. All right. So on the one side here, I'm just going to refer to the function as f of x. So the limit as x approaches, let's start with negative 3 from the negative side of f of x, and the limit as x approaches negative 3 from the positive side of f of x. Similarly, we're going to have to analyze the limit as x approaches 1 from the negative side, and the limit as x approaches 1 from the positive side. So those are the one-sided limit analysis. So every time you have a point of interest or an issue, so i.e. an asymptote, then you need to do that one-sided analysis. So in this case, there's two possible asymptotes. We have to do an analysis for each one. So some of your sketching skills are probably fairly good from MHF. It makes it quicker if you can come up with the sketch. So we know there's an asymptote at 1. We know there's one at negative 3. In between, so if I pick a value of 0, there's an x-intercept. There's a hole at 1. So that's actually a hole, that asymptote. Yeah, it's actually a hole. So we still have to analyze it. But when I'm doing my sketch here, I'm just talking to myself through the sketch. Okay. There'd be a hole at negative 1, and it would be located at, or at 1, sorry, 1/4 somewhere here. Okay. So if that is the case, it's also going to be the x-intercept. Okay, and so if I pick, let's say, negative 1, that would be a negative value. So I'm just developing the sketch here. That would be a positive. That's going to be negative, so the result's positive. So the graph is going to look something like this. Must be an asymptote. Hole goes through the hole. And if I go on the other side, make it, say, negative 5, that would be a negative. That becomes a negative, and that stays a negative, so it's negative. So the graph's down in this quadrant. So we got a graph roughly looking like that. Okay, so we're only worried about the asymptote. So when you plug in, when we do the analysis at negative 3, we're analyzing the behavior of the function at the asymptote. So we can see that from the negative side, it's going to head to negative infinity. As we approach negative 3 from the positive side, so the positive side again is from here. It looks like it's heading up to positive infinity. So therefore, discontinuous at x equals negative 3. For the other one, as we approach 1 from the negative side, we find that those values, they cancel out. So the approach or the approximate value here, in both cases, it looks like it's approaching 1/4. Okay. So, and the reason I know it's 1/4 is because technically the x minus 1s we cancel out. So we plug 1 into the equation, and in both cases it comes out to be 1/4. All right. From a graphical standpoint, so therefore it's continuous. As x approaches 1, the limit is 1/4. All right. And finally, my final example here is a piecewise function. And if you have trouble, if you don't know how to build the piecewise functions, I can do a lesson for that or talk to you in class with that. So that's the function f of x. Solid dots mean that that's the value in question. Anytime you have an open dot, it just means that the function ends there. It doesn't include the value. In this case, the value would be right there. So we're going to talk about that as we go. So the first example, the limit as we approach -4 from the negative side. So I find -4, 1, 2, 3, there's my -4. And as we approach it from the negative side, so it would be over here, it appears that the value, oh, sorry, my scale is supposed to go by 2s. My mistake, apologize. So approaching -4. So I'm going to come down my graph, heading towards -4. All right. As I approach it, it appears the value is going to have a y value of 0. Now, the next one, B part, is to approach -4 from the positive side, which means from the right side. So I'm going to get on the graph, and I'm going to slide down the line, and it too looks like it's going to be a value of 0. So C part is, what is the limit of f of x as we approach -4? And the answer is 0, because left side and right side agree. They both look like they share the value. So left side is equal to right side in the one-sided limit analysis. Now we're looking at 0. That's the point of interest. So approaching 0 from the negative side. So here, as I go up, it appears that the value is going to be 4. So it looks like it's going to have a value, excuse me, a value of 4. If I approach it 0 from the positive side, I'd have to get on the graph here and slide down the line, and it appears like it's going to have a value of 0. So what is the limit of f of x as we approach 0? Because the left side and right side are not in agreement, not equal to right side, there is no limit. It does not exist. Okay, so the limit does not exist. All right, moving on. What happens when we approach 4 from the positive, or sorry, from the negative side? So +4 from the negative side. So now I get on the line, and now I head upward. Okay, and it looks like it's going to be a value of 3. If I approach it from the positive side, I'd be getting on this curve here and sliding down the curve. And now it looks like it's going to have a value of 1. So once again, we have left side not equal to the right side. So when we ask what is the limit when x approaches 4, we would say does not exist. All right, so left side has to equal right side in order for it to exist. So the homework way down here for some reason, the hardest part in this homework is going to be coming up with piecewise graphs. So if you're unsure on how to do a piecewise graph, please ask in class, and I will do a quick lesson on how you are to graph, because I don't think it's in the curriculum, or you have dealt with it in the curriculum before. Okay, if you have any questions, you know where to find me. Good luck.